All right, guys, are there any questions on the homework? 17.
And also 19, but I'm mad at 19.
Okay. Do you have the...
Look at this. Look at this. I would have had to do just a negative 1. And I've like put it in like 3 million different ways.
Let me grab the assignment sheet. So 17, we can look at it first. So negative 3t squared plus 11t minus 6. So the first thing we can do is look at a greatest common factor. There's not one, but what we can factor out is the negative, which would give us 3t squared minus 11t plus 6. So the first thing I would do is factor out that negative. Yeah. So we can pull that negative out, which will make the 3t squared positive, the 11t negative, and the 6 positive. Now, since the third term 6 is positive, the signs are the same and match the sign of the middle term, which would be our minus and minus. Now, the factors of 3t squared, well, we'll have t and t, and then we'll have 3 and 1. Here? You want me to change it? Yeah. So you'll need t or x, or you'll need some variable. I'm not going to be a stickler about if you, instead of writing t, you wrote x on all of them. That's fine. I understand you're talking about the variable. I'm not going to be a stickler on that. But we will need 3 and, so 3x and x, 3t and t, either one of those. Because we factored out a negative from all three. So we pull a negative out of a negative, it becomes positive. And if we pull a negative out of a positive, it becomes...
So we have to do that to all of them?
Yes. Because essentially what we're doing is dividing everything by negative 1. Yeah. So it's making it, it's changing the sign. Now the factors of 6 that we can use are 2 and 3. And we can try this here. If we check this, 3t times negative 3 is negative 9t. Negative 2 times t is negative 2t, which gives us a negative 11t, which is what we wanted. So these here are the factors. No, that's right. You just left the negative inside.
Oh. Because on yours you got negative 11, and I got positive.
Right, because here I can factor the negative out of this.
Yeah.
Which would make that 3t. Since this is plus here, it's going to make it minus. Same answer, except you left the negative in.
So just change it to negative 11 or keep it that way?
You can keep it that way. I factor that negative out because then we're not having it affect the middle sign. Any other questions on this here? So we can look at 19. Negative 4c squared plus 19c plus 5. And again, I would start off by factoring out the negative, because that at least helps me see what the signs in the two parentheses are going to be. We'll have negative 3, 3. Since the 5, the third term is negative, our signs are positive and negative. They're going to be opposite. The factors of c are going to be c and c. And the factors of 4 are 1 and 4 or 2 and 2. For this one, I'm going to use 1 and 4. Because that middle number is pretty big. It's bigger than either 4 or 5. So I'm probably going to want some factors that are going to give me a big number. And we can do 1 and 5. 4c times negative 5 is negative 20c. 1 times c is plus c, which is going to give us a negative 19c, which is what we wanted. And we get this here. Any other questions on any of this here?
So because there's a negative in the front, that makes the positives a negative?
Yeah, since there's a negative here, I factor it out. I take it out of every single one and give us a negative out front. So it changes negative 4c squared to 4c. Plus 19 is now negative. Plus 5 is now negative. I pull it out so that really all the steps work. Because all the steps work the way they do, and step 3 works the way it does, is as long as kind of a is positive. So we pull it out to make it positive. If there's no other questions on that there, I want to go on and start with what we're doing today. Now, the first part of the notes, I believe I did leave blank. Yes, the zero product property. Now, before you start writing all of this here, so when the left side of ax squared plus bx plus c is 0 is factorable, and it's a factorable quadratic, you can solve the equation using the zero product property. Now, if the product of two expressions is 0, then one or both is 0. So according to the zero product property, well, if we multiply any two things together and they equal 0, what is the only way? So if I said I had A and I multiplied it by B and I said they're equal to 0, A times B is 0. What is the only number we can multiply anything by and get it to be 0? 0, yes? Because one of these has to be 0, because the only way we can multiply two things together and get 0 is if one of them is. Okay, so let's see here. Zero product property. If the product of two expressions is 0, then one or both of the expressions equal 0. That's all the zero product property is stating. So, if A and B are expressions and A times B is 0, then A is 0 or B is 0. So we kind of get the zero product property. So two things multiplied together to be 0 means one of them has to be 0. And what we've been doing is factoring, yes? Because we're rewriting this polynomial as two sets of parentheses being multiplied together. So if I look at this first one here, we're saying that what? K plus 1 times k minus 5 is? So if we want to solve this, we want to solve for what value of k is going to make this 0, well, if we have two things multiplied together to equal 0, one of them must be 0. We're saying that either the first set of parentheses, that k plus 1 is 0, or k minus 5 is 0. One of these has to be 0. Now with k plus 1, if I want to solve this, we do what? Subtract 1, telling us k is. That's one of our two solutions. Here we would add 5, telling us k is. So when k is negative 1 or 5, the value of this is going to be 0. And that's it. Those are the solutions. And yeah, because if we wanted to check it, you don't have to unless it specifically states it. Because we can say negative 1 plus 1 times negative 1 minus 5. I'm just plugging it in. Well, negative 1 plus 1 is 0. Negative 1 minus 5 is negative 6. And 0 times negative 6 is 0. So it did indeed give us a value of 0. We can do the same thing with 5. 5 plus 1 times 5 minus 5, which is going to be 6 times 0, which is indeed, and that's it. This here is one of the first methods we will have with solving quadratics. Questions on this here? Okay. Mm-hmm. So this here, again, we have two things multiplied together equals 0, so one of them must be 0. So we're saying that either 2m plus 3 is 0, or 4m plus 3 is 0. Both of them. Because one or both, they're both going to give us a value that works. And for every single quadratic, we'll get two solutions. They might not be unique solutions, because for here, it won't work, but we could get one where we said x is -4 and -4, where it's two values, but they're the same one. Now, the first thing we can do here is subtract 3 from both sides, which tells us that 2m is equal to -3. Then we would divide by 2, telling us m is 3/2 or -1.5. Then we'll do the exact same thing for the other one. We would subtract 3 from both sides, telling us that 4m is -3. Then we can divide both sides by 4, telling us m is -3/4. And that's it. Those are our two answers.
Is it okay if we do a decimal instead?
Mm-hmm. Yeah. I would, yeah, if you can write, I don't mind writing it as a decimal, because this here is -1.5 and -0.75, that's fine. Ninths, thirds, some of the twelfths, sevenths aren't too nice. Some of them that are ugly decimals, the non-repeat, or are kind of repeated decimal numbers, so 1/3 is 0.3 repeating. So some of those that just keep going on and on. If you can write those as a decimal or as a fraction, might as well. I don't mind which form, as long as you kind of, at least for each question, keep it kind of consistent. That's fine with me. As long as it is the correct answer. The form I don't care too much about, unless it specifically asks for it in a specific form, especially rational or in lowest and simplest radical form. Then we want it as a radical. Okay, let's look at the next one. So we have two things multiplied together to equal 0, yes? Well, not really. We have x squared plus 10x plus 21, right? If we can factor this, rewrite it as two sets of parentheses being multiplied together, then we can solve. That's where the zero product comes into play. So we'll work through our factoring like we did yesterday. Our first thing is to determine if there's a greatest common factor. Is there one? No. So we write our two sets of parentheses with 3 spaces. And this time it's equal to 0. Yes. Now we find the signs. If the third term is positive, the signs are the same and they match the sign of the middle term. Well, it is positive and the middle term is positive, so we have plus and plus. Now we need to find the factors of the first and third term. Well, the factors of the first term, x squared is x and. Now the factors of 21 are 1 and 21, or 3 and 7. And whenever I'm looking for the factors, I always start out with 1 and whatever the number is. Then I change, because that's always going to be one factor, 1 times the number. So here 1 times 21. And then I'll move the 1 up to the next number after it. Well, the next number after 1 is 2. Does 2 go into 21? Well, no, so it's not a factor. Then I go to 3. Is 3 a factor? Yeah, 3 is a factor. 3 times 7, yes? Yeah. And then I will keep going. I'll go 4, 5, 6, 7. And if the number that I'm doing, so 4 and the other number that goes into it, meet or go the other direction, where this number is now bigger than this number, we're done. Because those two ends will meet each other for factors. Now, out of these factors, which one do we want to try first? 3 and 7. And we can check this. Do our multiplication. Now, with this one here, we still have steps below it, don't we? But we still need to set them equal to 0 and solve if this does work. So when I check this here, I always check it off to the side. So for this here on your notes, you can do it to the right or left. Doesn't matter which. X times 7 is 7x plus 3x is equal to 10x. Is that what we wanted? Okay. So that means this is factored correctly, and I now have two things multiplied together that equal, which means for us that either x plus 3 is or x plus 7 is. And we can solve. So here we would subtract 3, telling us x is equal to -3. Here we can subtract 7, telling us x is equal to -7. Either one. We can put a comma in the middle. So you can leave it as both x equals 3, x equals -7, or we can do x equals -3, comma, -7. Any questions on any of this here? Are you ready for the next one? (4x squared plus 20x minus 24 equals 0). Well, again, they didn't give us two sets of parentheses equals 0. So we can factor this. Is there a greatest common factor between these three terms? 4. So we can factor the 4 out. And 4 out of 4x squared leaves us with x squared. Now, we didn't factor out a negative, so the signs will stay the same. 20 divided by 4 is, and we have x minus is equal to 0. Now we can do our two sets of parentheses with 3 spaces. So if the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, the signs are opposite. So one of them's positive, one of them's negative. Because if that third term's negative, does it really matter what the sign in the middle is? Not too much, because it's one's positive, one's negative. That's it. The only time we really look at the middle term is if the third term is positive. Now we could use it to determine like where the factors go and seeing how it's going to be for signs, but we mainly look at it when the third term's positive. Now the factors of x squared are x and. Now the factors of 6 are, or which one do we want to try first? 1 and 6. Which one do we want the 6 to be? Last thing we can do is check it. X times negative 6 is negative 6x. 1 times x is plus x. Negative 6x plus x is negative. Is that what we wanted? We need to switch the signs. So we need to make this positive, and this one here negative, which would mean we would have 6x minus x is 5x. That's what we wanted. Yes? Okay. Now, according to the zero product property, when we have two or more things multiplied together, they equal 0. One of them must be 0. Yes? Well, I know for certain that these two are here. I can plug a value in for x to make them 0. Yes? Can we do anything with that 4 out front? No, it's just a 4, right? There's nothing I'm plugging into it. So, am I really concerned with that 4? No, it's a constant term. So really all we're saying is that x minus 1 is 0 and x plus 6 is 0. Because one of these two is going to make it 0. The 4 is just a number. It's one of our scalars, so it's not going to affect the overall problem. It will change the rest of the graph. It just won't change where this is 0. And for the first one here, we can add 1 to both sides, telling us x is equal to 1. Here we can subtract 6 from both sides, telling us x is equal to negative 6. And that is it. Any questions on this here? Any other questions on anything we've done so far? Okay. Let's look at this one here. Now this one doesn't have a middle term, but it doesn't change anything. The steps are still going to be the same. Now the first thing we'll need to do is, one, I haven't set it up to this point, but we do need these equal to 0. And that's one of the things we'll start noticing as we continue on with this chapter and the next ones. If we have a power with a variable, so x squared, n squared, that's greater than 1, we need it equal to 0 to be able to solve, because we'll end up using the zero product property. So here it is equal to 0. Now, is there a greatest common factor between these two terms? 3, yes? And we can factor it out. And if we factor the 3 out, that leaves us with n squared minus 7 divided by 3 is 2, which leaves us with 15, and 15 divided by 3 is 5. No. Now, we have our two sets of parentheses with 3 spaces. Now here it's not really the third term, but it's still the same principle because the second term is not there, it's 0. So it's negative, which means the signs are positive and negative. They're opposite. So here, even though we don't technically, the 25 is not technically the third term, it's still really the third term. 75 divided by 3. Mm-hmm. Now the factors of n squared are n and n. Those are the only two factors. Now we need to look at the factors of 25. So we're still matching up with the 25. Because this is our first and 25 is our third. The middle term is 0. So the first term is n squared, so we have n and n. 25, we have 1 and 25, or 5 and 5. Which set of factors do we want to try first? 5 and 5? We can try it and see what happens. And if we check this here, n times negative 5 is negative 5n. 5 times positive n is plus 5n. And what's negative 5n plus 5n? So these are our correct factors. N plus 5 and n minus 5. More specifically, we call this setup the n squared minus 25 a difference of perfect squares. And now we can solve it because we have two things multiplied together to equal 0. So n plus 5 is 0, or n minus 5 is 0. And again, just like we did before, so here we can subtract 5 from both sides, telling us n is equal to negative 5. Here we can add 5 to both sides, telling us n is equal to 5. So for this one here, n is either positive 5 or negative 5. It could be either one. Any questions on any of these here? Do we feel comfortable with these here? Let's look at number 8. Now, for us to use the zero product property, the equation has to equal what? 0, yes? So before we can do anything, we need this equation to equal 0. So the first thing I can do is add 9p to both sides, which will tell us that we have 3p squared plus 9p minus 120. For most every single quadratic, there's only two methods that won't have it equal to 0. For most every single one, we're wanting this equal to 0. Because at this point here, we can factor out a greatest common factor, because we do have it equal to 0. And what goes into all three terms? 3. And if we factor 3 out of 3p squared, we're left with p squared. If we factor 3 out of 9p, we're left with 3p. And if we factor 3 out of 120, we're left with 40. Any questions on any of this here so far? Then we do the same thing we've been doing. 2 sets of parentheses with 3 spaces. Our signs. We look at the third term. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, our signs are opposite. Well, here the third term is negative, so one of them is going to be positive and one is negative. Now, luckily for us, we have p squared as the first term and negative, or just 40 as the third. Our factors of p squared are p and p. Now, the factors of 40. Well, we have 1 and 40, yes? We also have 2 times 20. Does 3 go into 40? No. 4 does, 4 and then 5 and 8. 6 doesn't go into it, and that's going to be it, because 8 or 7 doesn't go into it either, so we matched up to the other side. What is our middle term? 3, yes? So what's the likelihood that it's going to be 1 in 40? Not very likely, because our terms in front of P are 1 and 1, yes? So there's no way those will scale up. How about 2 and 20? Better than 1 in 40, but not likely. So that really leaves us with most likely 4 and 10 or 5 and 8. Which one do we want to try first? 5 and 8. Does it matter where I put the 5? 5 and 8. And we can check this here. So we would do P times negative 8 is negative 8P. 5 times P is plus 5P. Negative 8P plus 5P is, flip the signs. Which would make it 8P minus 5P is 3P. And then we can solve by our zero product property. P minus 5 is 0, or P plus 8 is 0. So for this one here, we would add 5 to both sides, telling us P is equal to 5. The other one, we would subtract 8 from both sides, telling us P is equal to negative 8. Any questions on any of this here? Any questions over anything we've done so far? You all need to see another example of one of these. So you feel comfortable with 9? Because 9's just like the 8. Any questions on 10, or want to see how 10's work? Now with 10, you can move it in 2 directions. You can either move the 14n and 21 over, or move the 7n squared over and just factor out that negative. And I'll go on and work it just so we can see it. Because we can subtract 7n squared from both sides, which will tell me that 0 is equal to negative 7n squared plus 14n plus 21. Bless you. I think this is a good one to see. Because is there a greatest common factor between these 3 terms? Yes. Because we do have the 7, yes? But I'm also going to take out the negative. Because I'd like to have the number in front of n squared, our variable that's being squared, to be positive. That's just me. Because if I factor negative 7 out of negative 7n squared, we're just left with n squared. Factoring out the negative is just changing the sign, and then we factor out the 7. So with positive 14, the negative being factored out is going to change it from positive to negative. 14 divided by 7 is 2n. And lastly, with 21, the negative is going to turn it from positive to, and 21 divided by 7 is, so we get this here. Now we can say 0 is equal to negative 7 parentheses, 3 spaces, 3 spaces. Since the third term is negative, our signs are opposite. One's positive, one is negative. Factors of n squared are n and n. Now the factors of 3 are 1 and, which spot do we want to put the 3? And if we check this here, n times negative 3 is negative 3n. 1 times n is a positive n, which will indeed give us a negative 2n. So these are the correct factors. Questions on this so far before we finish this up? Since we have 2 or more things multiplied together equals 0, it means that one of these 2 has to be 0. So for n plus 1 is equal to 0, we can subtract 1 from both sides, telling us n is equal to negative 1. And for our second one, we can add 3 to both sides, telling us n is equal to 3. So negative 1 or 3 are our 2 answers, and we do need both. Any questions on any of this here? And I believe that brings us to the end of this lesson. We have that. So your homework is a worksheet. That should be 3. Here's a 4th one for Evie.